Hello, good afternoon. Now I would like to introduce about myself. This is Venkatesh. Now I am going to give presentation regarding to the first unit of data structure. In this unit we are going to discuss about three things. The first one is called as asymptotic notation. Second one is arrays. Third one is linked list. So first I am going to give the demonstration regarding to asymptotic notation. Uh, See here, to solve any particular problem, we need to develop the solutions. Maybe the same problem having several solutions. Maybe the same problem having several solutions. Among these several solutions, we need to select the best solution. To select the best solution, or how we can say that the solution or an algorithm is best algorithm, is algorithm is nothing but already we know about that. Step-by-step procedure which is to solve particular problem. If maybe the same problem having several solutions, we need to select the best solution. How we can identify the solution is the best solution or algorithm is the best algorithm? Based on the two factors, one is time complexity and the next one is space complexity. Time complexity represents the amount of time that is required for executing an algorithm. Space complexity is represent the amount of space that is required for storing that algorithm. For any algorithm, if the time complexity and the space complexity are very less, we can say that that algorithm is efficient algorithm. So by using these two factors, time complexity and space complexity, we can decide the algorithm is best algorithm or not. Then, now here to decide the algorithm is the best algorithm or not, we can use time complexity and space complexity. But the time complexity of an algorithm is represented by using some symbols or by using some notations. That symbols or notations are nothing but asymptotic notations. I hope you understand what is the definition for asymptotic notation. These are the symbols or representations that can be used for representing the time complexity of an algorithm. Then to represent the time complexity of an algorithm, we can use three types of notations, three types of asymptotic notations. Actually the time complexity of an algorithm is represented in three ways. That is upper bound of time complexity, lower bound of time complexity, average bound of time complexity. So here I have used some notations, that is one is omega notation, theta notation, little omega notation, big O notation, theta notation, little omega notation, little big O notation. These are the five notations that can be used for representing the time complexity. But actually we can use only three notations. One is omega, next one is big O, and another one is theta notation. In the title itself we have the demonstration. Next, big O notation. When we can use this big O notation is, see here, big O notation, it represents upper bound of time complexity. It represents the upper bound of time complexity. Here already we have the formula C1 g of n is less than or equal to f of n is less than or equal to C2 g of n. So here actually first we have discussed about the theta notation. We can pronounce it as a theta notation. What is the theta notation can be used for representing the average time complexity. Average time complexity means here maybe for some algorithms the maximum amount of time and minimum amount of time both will be same. Here already in this formula we have, that is our f of n is lies in between C1 g of n and C2 g of n. Here C1 g of n is the lower bound, f of and C2 g of n is the upper bound. By seeing that graph representation also we can understand that here the time is lies in between the minimum amount of time and the maximum amount of time. So the minimum amount of time, if the time is lies in between minimum amount of time and maximum amount of time, that is denoted by theta notation. So because of that reason it is the entire graphical representation regarding to the theta notation. It represents average time complexity of an algorithm. Then next we can go for next slide, that is next omega notation. Omega notation represent lower bound of it represent big O notation. Okay, big O notation, it represent upper bound of time complexity. By seeing that graph itself, we can understand that here g of n is always greater than or equal to f of n. G of n is represent upper bound. Always it must be greater than to f of n. Upper bound is nothing but it represents the maximum amount of time is required for executing particular algorithm. That is nothing but that is denoted by big O notation. Next, go for omega notation. Already, as I have given a message, totally the time complexity is represented in three ways. That is the upper bound, lower bound, and average. Already, average is denoted by theta notation, and upper bound is denoted by big O notation, and next one is nothing but omega notation. Omega notation, it represents the lower bound of a time complexity. What do you mean by lower bound of a time complexity? It represents the minimum amount of time that is required for executing particular algorithm. Here we have f of n is equal to omega of g of n, that represent at this point n naught, the both functions f of n and c into g of n will be same. Here c is nothing but some constant value that always greater than 0, and here n naught represent inputs, that is also must be greater than or equal to 1. Why? Because input is always greater than or equal to, we have to give at least one input, so this, because of that reason, it is always greater than or equal to 1. So this is entire introduction regarding to the asymptotic notation that are used for representing time complexity of an algorithm. Next we can go regarding to relationship between all these three notations. First one represent average time complexity, second one represent upper bound, that is big O notation, and the next one represent omega notation. First graph represent average time complexity, second graph represent upper bound, and the third graph represent lower bound. Upper bound means maximum amount of time, lower bound means minimum amount of time. So this is entire